This is part 2 of the series Congruent Triangles, in which we're looking at relationships within and among triangles. And so let's look at two types of locations for angles in triangles. Here we have interior angles. Now an interior angle is an angle whose sides are the sides of the triangle, and an angle that is opposite another side, the third side of the triangle. Here we have an exterior angle. An exterior angle is an angle whose sides are one side of the triangle but an extension of an adjacent side. And notice this angle is not opposite any of the sides of the triangle. It points outward, points outward, points outward. Also note that an exterior angle forms a linear pair with its adjacent interior angle. So the interior and exterior angle pair is always going to be a linear pair. That's going to be an important distinction as we move forward. So let's go ahead and look at a relationship, an important relationship between the interior angles of a triangle. Now this relationship is called the triangle sum theorem. The triangle sum theorem states that the sum of the measures of the interior angles of a triangle is 180 degrees. So the measure of angle A plus the measure of angle B plus the measure of angle C is going to equal 180 degrees. Now to see where this relationship comes from, let's go ahead and generate the proof of this theorem. Now to prove this theorem, we don't quite have enough information just in this picture. So what we're going to have to do is we're going to add some information so that we can actually complete this proof. And one of the first things I'm going to do is I'm going to create a line that goes through point B, vertex B, that's parallel to AC. And that's going to set up some interesting angle relationships that we're going to use to our advantage. So I've gone ahead and pulled up our proof table, and I've added what's known as an auxiliary line here. I've added line DE through point B, and I made it parallel to AC, and I've put in some other marks in here to label these angles because we're going to be using these angles during the proof. So let's get started. We're given triangle ABC. So triangle ABC, and that's given. And I drew in line DB. So draw line DB parallel to segment AC. And that's going to be the parallel postulate. Parallel postulate says given a line and a point not on the line, there's exactly one line through the point parallel to the line. Now this creates a straight angle, DBE. So we know the measure of angle DBE equals 180 degrees. And that's the definition of a straight angle. Okay, now we know that angle 1 plus angle 2 plus angle 3 equals the measure of angle DBE. So measure of angle 1 plus measure of angle 2 plus measure of angle 3 equals measure of angle DBE. And that is the angle addition postulate. Now, because this equals 180, we can substitute in here. So we know that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180. And that's substitution property of equality. Now recall what we're trying to do here. We're trying to prove that the sum of angle 4, 2, and 5 equals 180. So somehow we're going to have to relate these angles to these two angles. And the way we're going to do that is taking advantage of this parallel relationship here. We can see that angle 1 and angle 4 are alternate interior angles. Two parallel lines cut by a transversal. These are alternate interior angles. And they're congruent alternate interior angles because these lines are parallel. Same thing with 3 and 5. So we can say that angle 1 is congruent to angle 4 and angle 3 is congruent to angle 5. And that's the alternate interior angle theorem. So now we can say the measure of angle 1 equals the measure of angle 4 and measure of angle 3 equals measure of angle 5. That's the definition of congruent angles. And now we can see that since the measure of angle 1 equals the measure of angle 4, we can replace angle 1 with angle 4. And since 3 equals 5, we can replace 3 with 5. So we can say the measure of angle 4 plus the measure of angle 2 plus the measure of angle 5 equals 180. And that is, again, the substitution property of equality. And we have just proven that the sum of the measures of the interior angles of the triangle adds up to 180 degrees. So let's go ahead and work some examples using the triangle sum theorem. So in this example, we have a triangle with an angle 48, 64, and we're looking for this angle. Well, using the triangle sum theorem, since all these angles add up to 180, we have 48 plus 64 plus x equals 180. So we add these two together, we get 112 plus x equals 180. Subtract the 112, x equals 68 degrees. And so there's a simple example of the triangle sum theorem. Now let's look at one more. So here we have a situation where we're not given any exact angle measures, and we have to use the triangle sum theorem. So we know this plus this plus this equals 180. So x plus 2x plus 3x equals 180. So we have 6x equals 180. Divide by 6, x equals 30. So that means this angle is 30 degrees. This angle is 2 times 30, which is 60 degrees. And this is 3 times, which is 90 degrees. Remember what we said earlier about never trusting the picture? Obviously, this does not look like a right angle, but it is, so never trust the picture. So here we have a 30, 60, 90 triangle. This is actually a right triangle, even though it doesn't look it. Trust your numbers, not the picture. So let's move on to something that's directly related to the triangle sum theorem. And this is the corollary to the triangle sum theorem. Now, a corollary is a statement or theorem that can be proven using the theorem or some other theorem. So in this case, the corollary to the triangle sum theorem says that the acute angles of a right triangle are complementary, meaning that they add up to 90 degrees. So measure of angle B plus the measure of angle C equals 90 degrees. Remember, the triangle sum theorem says the sum of the measures of the interior angles of a triangle is 180 degrees. So if we look at this from that standpoint, we can see that the measure of angle A plus the measure of angle B, that's a B, plus the measure of angle C equals 180. Now you can see that angle A is 90 degrees. So you have 90 plus the measure of angle B plus the measure of angle C equals 180. If we subtract 90, measure of angle B plus the measure of angle C equals 90 degrees. So clearly now you can see that the angle B and C are complementary because they're two angles that add up to 90 degrees. So that's the corollary to the triangle sum theorem. To look at an example of the corollary, it's basically a streamlining process. You don't really need it, but it's handy because it saves you an operation. So in this right triangle, we can see that this angle is 2x and this is 3x plus 4. So we know that these two angles are complementary, which means that 2x plus 3x plus 4 equals 90 degrees. So we add our like terms, 5x plus 4 equals 90 degrees. We subtract the 4, 5x equals 86, divide by 5, x equals 17.2. Remember, answers don't always come out neat and clean, so trust your process and you should be okay. So there's an example of the corollary to the triangle sum theorem. We could have used the triangle sum theorem itself. We could have set this plus 90 equals 180, but it would have been a wasted step, so there's no point. That's why we have a nice little thing like the corollary to the triangle sum theorem. So let's move on to the next section.